Hey, welcome to my channel Industry 4.0. Today, in this video, you will learn about the architecture, benefits, and challenges of microservices. Please like and share the video and subscribe to my channel. So, let's start the video. Microservices architecture. A microservice architecture style is an approach to developing one application as a suite of small services. Each runs in its own process and communicates with lightweight mechanisms, often an HTTP resource API. Microservices do have a distinct advantage: better organization. Microservice architecture is typically better organized. Each microservice features a really specific job, and it isn't concerned with the roles of other components. Decoupled services are also easier to vary, update, and reconfigure to serve the requirements of varied types of apps. They also leave fast, independent delivery of individual parts within a much bigger, integrated system. Performance. Under the right circumstances, microservices can also have a performance advantage relying on how they're organized. It's possible to isolate hot services and scale them independently of the rest of the app. Microservices-oriented cloud-native applications are built as a system of microservices. The overall idea of this style of architecture is to implement a system of multiple, relatively small applications. These are called microservices. They work together to supply the general functionality of your system. Each microservice realizes exactly one functionality: have a well-defined boundary and API, application programming interface used for communication. Gets developed and operated by a comparatively small team. Benefits of microservices. During a microservices architecture, services are fine-grained and thus the protocols are lightweight. Services are organized around business capabilities. Services are small in size, messaging-enabled, bounded by contexts, autonomously developed, independently deployable. This makes the appliance easier to understand, develop, test, and become more resilient to architecture erosion. Tons easier to implement and understand a smaller application that provides one functionality, instead of building an outsized application that does everything. That accelerates development and makes it tons easier to adapt the service to changed or new requirements. Since microservices are implemented and deployed independently of each other, i.e. they run within independent processes, they're going to be monitored and scaled independently. You would wish to stress tons less about unexpected side effects of a seeming chicken feed, and you will specialize in the event task at hand. It also allows you to scale more efficiently. And albeit you merely use a little neighborhood of the monolith, you still need to acquire additional resources for the other, unused parts. But during a cloud environment, you purchase the usage of hardware resources. Challenges using microservices. There is a saying, there's no such thing as a free lunch. Microservices remove some complexity from the services themselves and provide better scalability, but you're now building a distributed system. That adds a lot more complexity on the system level. To make sure that dependent services find each other and communicate efficiently, it's a challenging task when a number of microservices are many. We also need to handle slow or unavailable services so that they don't affect the complete system. The distributed nature of our system also makes it a lot harder to monitor and manage our system in production. Instead of a few monoliths, we now need to monitor a system of microservices, and for each service, there might be several instances that run in parallel.